Hello students, welcome to my channel Math Magic. Myself Provi Sarkar. Today we will discuss about the matrix. This is my part 2. This is my video, that is part 2. In part 1 matrix video, in part 1 I will discuss about the addition, subtraction, multiplication, adjoint of a matrix, okay, and properties, its properties. Now in this video we discuss about singular matrix, non-singular matrix, adjoint of a matrix, inverse of a matrix, and by using matrix method solve the simultaneous linear equation. Okay, so let's start. First of all, let's start, but one thing, if my video helps your study, so all of you share and like my video, share all of your friends to improve your study. Okay, now start. Matrix. Today we will start first singular matrix. So what is singular matrix? Okay, suppose a square matrix. Suppose a square matrix, singular matrix. Okay, suppose a square matrix A equal to, we indicate Aij. All of you see that Aij, A is element, I row number, J column number. Okay, so if a square matrix Aij, that is given, if determinant of A, matrix A is equal to 0, then the matrix is called singular matrix. Otherwise is called non-singular matrix. Okay, see, if determinant, we find the determinant of matrix, this is equal to 0, then this matrix is called singular matrix. Otherwise, that means determinant A not equal to 0, then this matrix is called non-singular matrix. Okay, now give an example, see carefully. Now give an example. Here, example number 1. Here is a matrix is given, a matrix A equal to, example number 1. Okay, a matrix A equal to, that is given 6x2, then 2 minus 1 2, then 2 minus 1 2, after that minus 10 5 2, minus 10 5 2, that is given, is a singular matrix. Okay, if A equal to this matrix is a singular matrix, then the question is find the value of x. Okay, clear? So singular matrix, that means determinant of that matrix is equal to 0. Okay, there is a square matrix, order is 3 into 3. So determinant of matrix A is equal to 0. Okay, that is the condition of singular matrix. Now see, determinant of 6x2, then 2 minus 1 2, after that minus 10 5 2, okay, is equal to 0. Now determinant of this matrix, see, 6 into determinant minus 1 2 5 2, okay, 6, eliminate this row and this column, this row and this column, so remaining part determinant minus 1 2 5 2, then minus x into determinant, eliminate this column and this row, corresponding column. So 2 minus 10 2, okay, then plus 2 into determinant, then eliminating row and column, 2 minus 1 2 minus 1, then minus 10 5 is equal to 0. Okay, determinant of this matrix is equal to 0. Now see the calculation, is equal to 6 into, see, minus 2, here is minus 2, minus 5 to the 10. So minus 2, here is minus 2, minus 10, then is minus x into 2 to the 4, minus become plus, 10 to the 20. Okay, then plus 2 into, okay, 5 to the 10, then minus 10 1 the 10, okay, is equal to 0. So 5 to the 10, 10 1 the 10, that is equal to 0. Now see, here is minus 2 minus 10, that is minus 12. So 6 into minus 12, that is minus 24, 6 into minus 12, that is 72. Okay, 6 into minus 12, 72, minus 24, 4 plus 20, that is 24x. is equal to 0. Here is 10 minus 10, that is equal to 0. So 74 minus 24 is equal to minus 24x is equal to 0. Now find the value of x. Okay, see carefully. That is minus 24x is equal to 72. Minus 24x is equal to 72. Okay. Now see. Therefore x is equal to minus 72 divided by 24. Okay. So value of x, that is equal to minus 3. Okay. 3 24 the 72. That is x equal to, that is value of x equal to minus 3. Got it? Okay. See carefully. Hope all of you understood. Come to the next. Okay. Come to the next point. Next is singular matrix, all of you know. Next is adjoint of a matrix. Okay, first of all, listen what is adjoint of a matrix. Okay, see carefully. If let A adjoint of a matrix. Okay, let A equal to Aij is a matrix, obviously square matrix. Okay, let A equal to Aij is a square matrix whose order greater than equal to 2. Okay, then the adjoint of A is the transpose of the matrix. Therefore adjoint of A is the transpose of the matrix capital Aij. Okay, capital A. What do you mean by capital A? Capital A means cofactor of all the elements of the main matrix. Okay, so if we A equal to Aij is a square matrix, then adjoint of a matrix, that is equal to capital Ai transpose of capital Aij. So capital Aij, what does it mean? Capital Aij, that means cofactor of all the elements of the original matrix. Okay, now come to the example, so for your better understood. Okay, come to the example. See here, adjoint of a matrix. How to find out the adjoint of a matrix? Okay, now first listen the question. Find the adjoint of a matrix A equal to, example number 2. Find the adjoint of a matrix A equal to, that is given, A equal to 1 0 minus 1, 1 0 minus 1, then 3 4 5, 3 4 5, then is 0 minus 6, 0 minus 6 minus 7. Okay, that is given. The question is find the adjoint of a matrix. Okay, so see how to find the adjoint of a matrix. Okay, this element, first element is A11, then A12, then A13, then 21, then A22, then A23, then A31, A32, then A33. This is the element of that matrix. Okay, first one is called A11. Now find out the cofactor of all the elements. Okay, how to indication of cofactor? Indicate cofactor, capital A11. Okay, see capital A11. First of all, you find all of the cofactors of all the elements. Okay, see capital A11. Okay, first of all, capital A11, that means this. So eliminate first column and first row. Eliminate first row, first column. So we get minus 1 whole to the power 1 plus 1 into determinant of 4 5 minus 6 7. 4 5 minus 6 minus 7. Got it? Minus 1 whole to the power 2, that is 1. Okay, so determinant of this minus 4 7 the 28, minus 28, here is plus 30, 5 6 the 30. So minus 28 plus 30, that is 2. So cofactor of first element, that is 2. Okay, now cofactor of A12, that means 0. Cofactor of A12. Okay, see O12, that means minus 1 whole to the power 1 plus 2. Okay, to better understood the cofactors of how to find out the cofactors, you see my determinant video. Better understand you how to find out the cofactors. Okay, now see A12, eliminate this first row, second column, first row, second column. Okay, minus 1 whole to the power I, 1 plus 2, 3, 5, 3, then 5, 3, 5, 0 minus 7, 0 minus 7. Okay, so minus 1 whole to the power 3, minus 1, then minus 3 7 the 21 minus 0, so minus 21. Here is also minus, so 21. Okay, then A13. Okay, so how to find 1 3? A13, that is equal to eliminate first row, third column. So we get minus 1 whole to the power 1 plus 3, determinant of 3 4 0 minus 6, 3 4 0 minus 6. Okay, so we get minus 1 whole to the power 1 plus 3, that is 4, become plus. So minus 3 6 are 18, minus 18, 4 0 0, so we get minus 18, A13. Now A21, capital A21, capital A21, the identification mark of the cofactor of this element. Okay, so capital A21 equal to minus 1 whole to the power 2 plus 1, eliminate second row, first column, second row, first column. So 0 minus 1 minus 6, 0 minus 1 minus 6 minus 7. Got it? So 0 minus 1 minus 6 minus 7. Okay, so we get minus 1 whole to the power 3, that is minus, and here is 0 minus 6, that is plus 6. Got it? Now after that A21, that is A22 is equal to minus 1 whole to the power 2 plus 2, determinant of eliminate second row, second column. So second row, second column. So 1 minus 1, 0 minus 7. 1 minus 1, 0 minus 7. Okay. So the answer is minus 1 whole to the power 4, that is plus. So minus 1 into 7, 1 into minus 7, that is minus 7. Okay. Now A23, eliminate second row, third column. Second row, third column. So there is minus 1 whole to the power 2 plus 3, then determinant of 1 0 0 minus 6, 1 1 0 1 0 0 minus 6. Got it? So the answer is minus 1 to the power 5, that is minus, here is minus 6, that is only 6. Clear? Next is A33. Okay, so A33, we got A33, that means A23, then A33, that means 5. Okay, that means, sorry, A23, then okay, A23, A21, A23, we find out the cofactor of all the element of the second row. Now A31, not A33, now find out A31. A31, that is minus 1 whole to the power 3 plus 1, eliminating third row, first column. Third row, first column. So there is 0 minus 1, 4, 5. 0 minus 1, 4, 5. Okay, so what is the answer? Minus 1 whole to the power 4 become plus, then minus of minus 4, that is plus 4. Okay, now A capital 3 2. Okay, so again minus 1 whole to the power 3 plus 2, determinant of eliminating third row, second column, that means third row, second column, 1 minus 1, 3 5, 1 minus 1 3 5. Okay, so minus 1 whole to the power 5 remain minus, so 5 ones are 5 plus 3 ones are 3, 5 plus 3 8, that is minus 8. Now last one, A33. Okay, so A33, third row, eliminating third row, third column. So we get 1 0 3 4, minus 1 whole to the power 3 plus 3, then determinant of 1 0 3 4, 1 0 3 4. Okay, what is the result? That is 4 ones are 4, and minus 1 whole to the power 6 plus, that is 4, only 4. So we find out all the cofactors of all the element. Okay, now see, therefore adjoint A, we indicate that ADJ, adjoint A, is equal to, write all the cofactors, that is A11, okay, that is 2, then A12, that is 21, after that A13, that is 18, minus 18, okay, then A21, that is 6, put the value, then minus 7, then A23, that is 6, then 31 4, then minus 8, then again 4. Okay, and transpose. Okay, so adjoint A is the cofactors, find out the cofactors of all the element and got transpose. Okay, so adjoint is equal to transpose mean interchanging row and column, that is 2, 6, 4, 21, minus 7, minus 8, minus 18, 6, 4. Okay, that is we get the adjoint. Okay, so A matrix is given, A square matrix order 3, that is given. Find out the adjoint of the matrix. This is the process how to find out the adjoint of a matrix. Clear? See carefully. Hope all of you understood. Next sum. Go to the next sum. Next is inverse of a matrix. Next is inverse of a matrix. Okay, see carefully. How to find out the inverse of a matrix? See, how to find out the inverse of a matrix. Okay, first of all, see, if a square matrix, if A is a square matrix, then A inverse exists if determinant A not equal to 0. Okay, see carefully. If A is a square matrix, A is a square matrix, Aij, A is a square matrix, and determinant A not equal to 0. This is the main condition. Determinant A not equal to 0. Okay, if A is a square matrix, order greater than equal to 2 and determinant A not equal to 0, then A inverse, that means A to the power minus 1 equal to 1 by determinant A into adjoint. Okay, adjoint in previous sum we find out the adjoint. Okay, so A is a square matrix, then A and A determinant A not equal to 0, then the formula find out the A inverse, that is A inverse equal to 1 by determinant A into adjoint. Okay, now see, there is an example. Find the inverse of a matrix. Example number 3. See, example number 3. Find the inverse of a matrix that is given. Matrix is given. That is 3 minus 1, 1. 3 minus 1, 1. After that, minus 15, 6, minus 5. Minus 15, 6, minus 5. Then 5 minus 2, 2. Then 5 minus 2, 2. Okay, this is a matrix that is order is 3, that is, or square matrix order is 3, that is given. Okay, find out the inverse of a matrix. First of all, we find out the determinant of matrix A. So determinant A, okay, that is 3 into determinant of 6 minus 5 minus 2, 2 minus of minus 1, determinant of minus 15 minus 5, then 5, 2. Okay, then plus 1 into determinant of minus 15, 6, then 5 minus 2. Okay, got it? Then after calculation, we get the value of determinant A, that is equal to 1. That is equal to 1. Got it? Determinant A equal to 1. After calculation, we get the value. Now find out the adjoint. Okay, so adjoint A equal to, see carefully, adjoint A is equal to, again find out the cofactor, again find out the cofactor of all the elements, again find out the cofactor of all the elements. Okay, so cofactor of 3. Now see calculation in the previous sum, calculation is same as the previous sum. So cofactor of first element, that is after calculation we get 250, 250, then is 0, 1, 1, 0, 1, 1, then is minus 1, 0, 3, minus 1, 0, 3. Okay, after calculation we get the cofactor of all the elements. Cofactor of 3, that is 2, cofactor of minus 1, that is 5, cofactor of 1 equal to 0, calculation in the previous sum, same way, using same process we find out the cofactor of all the elements. Okay, now therefore the A inverse equal to 1 by determinant A, that is 1 by 1 into adjoint A. Oh, see, here we find out the transpose of this adjoint A. Okay, how to find out transpose? Just interchanging row and column. That means 2, 0, minus 1. Then 5, 1, 0. After that 0, 1, 3. Okay, so 1 by determinant A, that is 1 by 1 into adjoint is here 2, 0, minus 1. After that 5, 1, 0. Then 0, 1, 3. Okay, that means 1 into this, that means this. So finally we find A inverse equal to 2, 0, minus 1, then 5, 1, 0, then 0, 1, 3. Got it? So see how to find out A is a square matrix, order 3, that is given. How to find out the A inverse of that matrix? This is the process. This is the answer. See carefully. Next is another important, that is in your board exam, come on your board exam, that is very important. Okay, that is very important. That is by using matrix method, solution of a system of linear equations using inverse of matrix. Okay, so solution of system of linear equations using inverse of a matrix is called matrix method or Martin's rule. Okay, is called matrix method or Martin's rule. Okay, so there is, see carefully, this is example number 4. Okay, see carefully, a system linear equation that is given. See, x minus 2y equal to 10, x minus 2y equal to 10. Okay, then next equation is 2x plus y plus 3z equal to 8. 2x plus y plus 3z, 2x plus y plus 3z is equal to 8. Then is minus 2y, then is minus 2y plus z, minus 2y plus z equal to 7. Minus 2y plus z is equal to 7. Okay, there is a three linear equation that is given. First one is x minus 2y equal to 10. Then second one is 2x plus y plus 3z equal to 8. And third one is minus 2y plus z equal to 7. So the question is, by using matrix method, other's name is Martin's rule, by using matrix method, solve this system linear equation. Okay, how to find? See carefully. First of all, A equal to, write all the coefficients of this equation, x, y, z. Okay, here coefficient of x 1, coefficient of y minus 2, coefficient of z, that is 0. Okay, not given, that means 0. Okay, then here is 2, 1, 3, and third equation x, the coefficient of x is not given, that means 0 into x, that is 0. So coefficient of x 0, here is minus 2, here is 1. Okay, we get the value of A. Then B equal to, write the constant term, write all the constant term, that is 10, 8, 7. 10, 8, 7. Okay, then capital X is equal to, write the variables. Here variables is x, y, z. X, y, z, that is the variable. Okay, now the formula is, listen carefully, now the formula is Ax equal to B. Ax equal to A into x is equal to B, or x is equal to A inverse into B. X is equal to A inverse into B. Okay, that is the way we find out the value of x, that means variables x, y, z, by using matrix method, other name is Martin's rule. Okay, see how to find. First of all, if determinant of A must not be equal to 0. Determinant of A must not be equal to 0. If 0, then not possible to solve this equation. Okay, so determinant A, first of all we check determinant A must not be 0. So first of all find out the determinant A. Okay, therefore determinant A, that means determinant of this matrix. Okay, So after calculation, determinant of the, how to find out the determinant already we discussed. Okay, so determinant of this matrix is equal to 11. After calculation we get determinant of matrix is equal to 11. Okay, now next one is adjoint A. Okay, so adjoint A is equal to determinant A is equal to 11, that is not equal to 0. Then the solution of this equation is possible. Okay, now check how to solve this. Adjoint A, find out the adjoint A, how to find? That means find out the cofactor of all the elements. Okay, find out the cofactor of all the elements and transpose this. We get the adjoint A. Okay, so adjoint A, cofactor of the cofactor of the first element. Okay, using same process, same calculation already discussed. I already discussed in this previous sum. So adjoint A, that means cofactor of all the elements. So cofactor of 1, that is 7. Okay, cofactor of -2, that is -2. Okay, then cofactor of 0, that is -4. Okay, then cofactor of 2, that is 2, that is 2. Cofactor of 2, that is 2. Cofactor of 1, that is 1. After calculation we get cofactor of 3, that is 2. Okay, then cofactor of 0, that is -6. Cofactor of 0, that is -6. Cofactor of -2, that is -3. Cofactor of 1, that is 5. Okay, and transpose. So we get the adjoint A. So adjoint A, after transpose this matrix we get 7, 2, interchanging row and column, 7, 2, -6, after that -2, 1, -3, then -4, 2, 5. Okay, so after transpose of this matrix we get this value. This is the value of adjoint A. Okay, now adjoint A, we get the adjoint A. Next, A inverse. Therefore A inverse is equal to 1 by determinant A, that means 1 by 11 into adjoint A, that is 7, 2, -6, then -2, 1, -3, then -4, 2, 5. Okay, then we get the A inverse. Okay, now X equal to A inverse into B, that is the formula. Okay, see, therefore X is equal to A inverse, that is 1 by 11 into adjoint, that is 7, 2, -6, then -2, 1, -3, then -4, 2, 5. Okay, into B. B means 10, 8, 7. 10, 8, 7. Okay, so we multiply this, we get 1 by 11. 1 by 11 remains same. Now do the product. First check this product is possible or not. Order of this matrix equal to 3 into 3 and order of this matrix equal to 3 into 1. Okay, there is 3 row, 3 column. Here is 3 row but 1 column. So order of this matrix 3 into 2, 3 into 3, and order of this matrix 3 into 1. Now how possible this product is possible? So what is the main condition? Listen carefully. This column number of the first matrix is equal to row number of the second matrix. If they are equal, then the matrix product is possible. Here column number of the first matrix 3, here row number of the second matrix, that is 3. So 3 equal, so matrix product is possible. So see, 7 into 10, 7 into 10, that means 70. Then plus 8 into 2, 16, minus 6 into 7, that is 42. Okay, then minus 2 into 10, minus 20, then 1 into 8, plus 8, then minus 3 into 7, minus 21. Got it? Then minus 4 into 10, minus 40, then 2 into 8, plus 16, then 5 into 7, plus 35. Okay, so let's calculate. 1 by 11, that is 1 by 11 into 70 plus 16 minus 42, that is we get 44. Okay, then minus 20 plus 8 minus 21, we get that is 33, minus 33. After that minus 40 plus 16 plus 35, The result is 11. Okay, the result is 11. Okay, now see what's happened. X means xyz. Okay, now see, after multiplication 1 by 11, each and every element we get 4 minus 3 1. Okay, so here x means x, y, z. Okay, so comparing both side we get x equal to 4. Therefore, comparing both side we get x equal to 4, y is equal to minus 3, and y is equal to minus 3, and z is equal to 1. Okay, y is equal to minus 3 and z is equal to 1. So comparing both sides we get the value of x equal to 4, value of y equal to minus 3, z is equal to 1. Okay, so see carefully. By using matrix method or Martin's rule, another name of matrix method, that is Martin rule. So by using matrix method or Martin rule, we solve, this is the process to solve the simultaneous linear equation. Okay, got it? Okay, thank you students.